Good day everyone, this is Mary Antoinette Batucan, a 3SM student, and today I am going to present to you 3 items from our M3111 Calculus 3 Final Task Solution Set. So let us begin with item number 1, letter B. So for item number 1, letter B, we have to integrate first integral 0 to y of square root of 9 plus y squared dx. So we have to integrate and plug in y and 0. So we have an integral of 0 to 4 square root of 9 plus y squared y minus square root of 9 plus y squared 0 dy. So when we integrate that, so it is known that when a constant is multiplied to 0, the answer is 0. So we have to cross that out. So we will remain with the square root of 9 plus y squared y. So we integrate that for the second integration. So integral 0 to 4 square root of 9 plus y squared y dy. So we plug in 4 and 0, but before we do that, we need to get the antiderivative of our value. So the antiderivative of our value is square root of 9 plus y squared times 9 plus y squared over all over 3. So we plug in 4, that is square root of 9 plus 4 squared times 9 plus 4 squared over 3 minus, then we plug in 0, square root of 9 plus 0 squared times 9 plus 0 squared over 3. So we have the value for when we plug in the 4, 5 times 25 over 3 and 3 times 9 over 3 in 0. So we have the value 125 over 3 minus 27 over 3. Since we have the same denominator, we subtract the numerator directly. So we have our answer 98 over 3 units. So the answer from our given integral of 0 to 4 and integral of 0 to y square root of 9 plus y squared dx dy is 98 over 3. Let's move on to our second item, item number 2. So find the volume of the solid in the first octant bounded by the paraboloid z is equal to 9 minus x squared minus 3y squared. So we all know that x squared plus y squared is equal to r squared. And f of x and y is equal to 9 minus 3 times 3x squared plus y squared, and f of r and theta is equal to 9 minus 3r squared. So we get the value of r. So we evaluate the 9 minus 3r squared. So we have our value for r, that is square root of 3. So from the figure, we can see that we have now our upper bounds and lower bounds for the first and second integrals. So for the solution that is shown in the screen, so we have to integrate first integral 0 to square root of 3, 9 minus 3 r squared r dr. So first, before we integrate, we have to get the antiderivative of our value. So we have 9r squared over 2 minus r to the power of 4 over 4. So when we plug in, then we plug in a square root of 3 and 0. So we have the values for the square root of 3, 9 times square root of 3 squared over 2 minus 3 square root of 3 to the power of 4 over 4 minus 0, since we all know that when we multiply any value to 0, it will result to 0. So we have now the result for our first integration, 27 over 2 minus 9 over 4. So that is 45 over 4. So then we have to integrate our second integral, integral 0 to 2 pi, then we have now, we have to plug in the upper and lower bounds. So 45 over 4, 2 pi minus 45 over 4 times 0. So we have our value 45 pi over 2 minus 0. So the volume of the solid in the first octant bounded by the paraboloid z is equal to 9 minus x squared minus 3y squared is 45 over 2 pi cubic units. So for last item, we have item number 7. Find the area of the surface of the portion of the cylinder x squared plus z squared is equal to 4 that is inside the cylinder x squared plus y squared is equal to 4. So we have our given x squared plus z squared is equal to 4 and x squared plus y squared is equal to 4. So from that, we can get the value of the x, y, and z. So we have our value for z, that is positive negative square root of 4 minus x squared, and we have our x sub 1 that is equal to negative 2 and x sub 2 that is equal to 2. Then we have y that is equal to negative square root of 4 minus x squared, and then we have the value for y squared that is square root of 4 minus x squared. So we have to integrate. So from the solution in the screen, so we have fx squared times xy plus fy squared times xy plus y dy. So we have to integrate that first. So the upper and lower bounds for our first integration would be from the integral from negative square root of 4 minus x squared to positive square root of 4 minus x squared. So first we have to get the antiderivative of our value, and then we plug in the upper and lower bounds. So we have here 16 integral of negative 2 to 2, 1 over square root of 4 minus x squared y. That is when we integrate the lower bound, which is the negative square root of 4 minus x squared, and the upper bound 4 minus x squared. So we plug in that upper bound and lower bound. So we have 16 integral of negative 2 to 2, 2 times square root of 4 minus x squared over square root of 4 minus x squared dx. So we have 32 integral of negative 2 to 2, 1 dx. So when we get the antiderivative of 1, that would be x. And then we have to plug in our lower and upper bounds, negative 2 and positive 2. So we have 32 times 2 minus negative 2, that would be 2. 2 minus negative 2 is 4, so we have 32 times 4. So the area of the surface of the portion of the cylinder x squared plus z squared is equal to 4, that is inside the cylinder x squared plus y squared is equal to 4, would be 128 square units. Thank you so much for listening and have a good day.